Hello, we're here today to look at section 5.5 and section 5.6 on multiplying polynomials. So once again, if you have not already filled in the notes page, page 141 of the notes, you should probably go do that. It's pretty short this time, as you can see. So take a break, go do that, and come back. So, objective 1 is multiplying monomials. Multiplying monomials, the way that I look at this is you're doing multiple problems at once. Basically, you're multiplying the numbers and then the variables separately. So negative 6 times 5 is 30. X times x cubed is x to the fourth. You add those exponents. All right, let's skip over here to letter C. 6 times 12 is 72. M times m is m squared, and n cubed times n is n to the fourth. Next, we have objective 2, multiply a monomial by a polynomial. These follow the distributive property that we've already discussed in the class, which is that if you have a number, or in this case a term, outside of a parentheses, it multiplies in times each of the terms, and you keep those signs in between. So 2m times 3, 2 times 3 is 6, m. 2 times 7 is 14, and m times m squared is m cubed. And 2 times 3 is 6, and m times m cubed is m to the fourth. Let's take a look down at letter D. 8 times 4 is 32. M times m is m cubed, and this n is just along for the ride. Plus 8 times 5 is 40. M times m is m squared, and n times n is n squared. Dealing again with the numbers, then each letter individually. And the last one, 8 times 7 is 56. M, there are no more m's, so we just leave that. And then n times n squared is n cubed. And we're done. Now the main course of this section is objective 3, which is multiply two polynomials. And I will tell you that most people, including your textbook, teach a method called FOIL. I am going to do one problem with FOIL. The first one I have done in many years. I am not a big fan of FOIL, but it works. It just doesn't expand to work in other situations, which is why I don't like to use it. But I will use it here. So what it says is multiply the first terms. 2x times 3x is 6x squared. Multiply the outer terms. 2x times 4 is 8x. Multiply the inner terms. 5 times 3x is 15x. And then multiply the last terms. 5 times 4 is 20. 6x squared plus 23x plus 20. So that will work on every problem. And if you like to remember things first, outside, inside, last, it totally works on this. Now, here's the reason that I don't love it. And I'm kind of on a crusade on my own on this. Most everyone that I've met likes FOIL. I just don't. But you can use it. It's totally fine. A, it doesn't work in other situations. Like, it doesn't work on these problems we just did back here that were the distributive property. It also wouldn't work if there were three things in this parentheses over here, like 3x plus 3y plus 4. FOIL would no longer work. It only works on these binomial times binomial problems. And then the other thing is it makes it feel like it's some kind of mystery why you're multiplying the things that you are. It's just to make this FOIL thing happen. No, there's a reason you're multiplying what you're multiplying. And that reason is that you are you're doing the distributive property, you're just doing it twice. So you're doing 2x times everything in that parentheses. and then 5 times everything in that parentheses. And I much prefer to think about it as the distributive property that way than I do using FOIL. And number 2 is a really good example of why FOIL would not work here, because I wouldn't get every term. So what we want to do is take x times every term. So x times x is x cubed. X times minus 3x is minus 3x squared. And x times 9 is 9x. Then we go back and take 3 times every term, which I can't write over there because I'm out of space. 3x squared minus 9x plus 27. Now we combine our like terms. I've got x cubed. If I put minus 3x squared with plus 3x squared, those are going to disappear. If I put 9x with minus 9x, those are going to disappear. And then I have plus 27. So that's x cubed plus 27. Let's do another one. How about number 5, which has 3 terms times 3 terms. In fact, it's something times itself, which is interesting, but we're going to do the same thing. Take each one of these terms and distribute it into the other one. So I'm going to do y squared times y squared is y to the 4th. Y squared times minus 2y is minus 2y cubed. Y squared times minus 3 is minus 3y squared. Then I'm going to take minus 2y times y squared. That's minus 2y squared. Minus 2y times minus 2y, that's going to be plus 4y squared. And minus 2y times minus 3, that's going to be plus 6y. And last, minus 3y squared. Minus 3 times minus 2 is plus 6y. And minus 3 times minus 3 is plus 9. Now I can combine my like terms. So if I look fourths, I just have y to the 4th. If I look at cubes, I should have more of these. I think I made a small error somewhere, because I should have y squared times minus 2y would be 2y cubed. And then I should also have minus 2y times y squared. This should be cubed right here. So I have minus 2y cubed right there. So I have minus 2y cubed, and another minus 2y cubed is minus 4y cubed. I have minus 3y squared plus 4y squared minus another 3y squared. That's negative 3, and negative 3 is negative 6, but plus 4, so that's negative 2y squared. I have plus 6y and plus another 6y. That's plus 12y. And then lastly, I have a 9. Now, objective 4 is just multiplying binomials, and it says by the FOIL method. I'm not going to do that. Once again, you can go through with that first, outside, inside, last, and multiply that way. I think it's much better just to continue with our distributive method. So 3x times 2x is 6x squared. 3x times negative 3y is negative 9xy. 2y times 2x is plus 4xy. And it could be yx, but I like to write them all xy. They're the same. And then 2y times negative 3y is negative 6y squared. If you combine these middle terms, you get minus 5xy minus 6y squared. Now, if you happen to write those as xy and yx, remember that they really are the same because you can multiply in any order, commutative property, so you would need to combine them still. The rest of these are all going to work out the same. Maybe this one's mildly interesting, but the fractions, let's work that out. X times x is x squared. X times negative 4/3 is negative 4/3 x. Negative 1/3 times x is negative 1/3 x. And negative 1/3 times negative 4/3 would be 4/9. Well, that's x squared minus 5/3 x plus 4/9. Okay, what is wrong with each of the following multiplication answers? Well, on this one, they should have distributed the -3, and you can see the problem is the 3 should be -3. And on this one, this is one of the most common mistakes in mathematics right here. When you have a square on the outside here, you do not just square everything on the inside. That is the rule if you have something like 3x squared squared. That becomes 9x squared. But that's not what this means. 3x plus 2 squared means 3x plus 2 times 3x plus 2. And if you work that out, you get 9x squared, which is what they have. You would also get a 4 from 2 times 2, but what you're missing is 3x times 2 and 2 times 3x, which are another 2 6x's, which makes it 12x. So that's what's missing here. All right, that is section 5.5. Once again, you may want to head over to the textbook. This claims it's page 402 and page 404. I'm not 100% sure of that, but anyway, we're on page 145 of the notes, and this is a section on special products. Now, what I have to say about these special products is that they are shortcuts, and you may or may not remember them. Your future in algebra does not really rely on knowing this section all that well. They come up kind of rarely, and you can usually get by without them. The first one is square binomials, and the rule for square binomials, which is what we just had at the end of the last video that we did, is this turns out to be a squared plus 2ab plus b squared. Now maybe the best thing about this section is just understanding how a formula like this works. So if you have a binomial that looks like a plus b, and it's squared, so that's something plus something else squared, you get the first something squared plus 2 of them multiplied together plus the second something squared. So for example, on this problem, our a is 5y, and our b is -3. So a squared would be 5y squared plus 2 times 5y times -3 plus -3 squared, which is 25y squared. 2 times 5 times -3 is -30y, and then -3 squared with the parentheses like it is a +9. So we use the formula to work this out and get that answer. This is, again, probably not the most useful formula, because we could have just worked this out. 5y minus 3 times 5y minus 3 is 25y minus 15y minus 15y plus 9, which is 25y squared minus 30y plus 9. I missed the square there the first time around. I think this is faster just to realize what square means and work that out than it is to try to use the formula. But understanding how to use the formula is good, because we do use this for cubic formulas and things that come along, because those are more annoying to multiply out. And we use them backwards for factoring formulas later. Okay, I'm not going to go through any more of this type. I would encourage you can work them out this way, or you can just, work them out with the distributive property like all the rest that we've done. Just write 7 plus x times 7 plus x and work it out. All right, the one that is a little more useful, again, totally not needed, but it comes up quite often and is very handy, is if you have a binomial times its conjugate. And what that means is you have something of the form a plus b times a minus b. So in our case, that's 12 plus x times 12 minus x. Our a is 12 and our b is x. The formula for that is you get a squared minus b squared. So in our case, we're going to get 12 squared minus x squared, which is 144 minus x squared. That's fast. And why does that happen? Well, if you were to go in and distribute it out, you get the 144. You would get minus 12x, you would get plus 12x, and you would get minus x squared. So what you can see is those middle terms cancel out because these signs are opposite. And that's exactly what happened over here. So let's run down and do number 11 just because it's got fractions. I know what's going to happen with this is the middle terms are going to cancel. When I work this out, I'm going to end up with a squared minus b squared. My a here is 3/4 s. My b is 7/5 t. So if I square this, I would get 9/16 s squared. Minus, if I square this, I get 49/25 t squared. Again, if you don't remember the formula, the a squared minus b squared, you can just start to multiply it out. You would get that 9/16 s squared. You would get 21/20 t, a minus version, but then you get the plus version from here, and they would just cancel out. And then you would get your minus 49/25 t squared from this second term multiplication. So if you notice this is handy. This is also useful later on when you're dealing with square roots and imaginary numbers and all kinds of things in Math 091 if you need to take that course. Okay. This next step, finding greater powers of binomials. These can get rather obnoxious just because the problems get very long. So if we look at a minus 3 cubed, there is a formula for this, but most people don't have it memorized, including me. What we're going to do is just work it out the long way. A minus 3 times a minus 3 times a minus 3. And the way you're going to do that is just do a minus 3 times a minus 3 to start. That's going to be a squared minus 3a minus another 3a plus 9. That's a squared minus 6a plus 9. And then we're going to take that times a minus 3 again. So we're going to get an a cubed. We're going to get a minus 3a squared. If you take 6a times a, that's minus 6a squared. Minus 6a times minus 3 is minus 18a. Actually, plus 18a. 9 times a is 9a. 9 times negative 3 is minus 27. Combining terms, that's a cubed minus 9a squared plus 27a minus 27. Now this one is a fourth power. That's going to be worse. You're going to do 2z plus 5y times 2z plus 5y times 2z plus 5y times 2z plus 5y, and you're going to do the same process. Multiply these two, get an answer. Then multiply it by another one, get an answer. Then multiply it by another one, get an answer. And it's going to be quite a long answer. All right, the last one we're going to do, scrolling down to number 16, we're going to look at what is wrong with these products. Well, I can tell immediately, and I don't know that I'm going to correct any further than this. I noticed that they did the same thing. The middle terms are missing. There should be some PQ terms here. They squared the 2p, they squared the 5q, but they didn't put the middle terms, so missing middle terms. Should have written this out and multiplied or used the formula for the perfect square, or for squaring binomials. And B, what's wrong? Well, these are conjugates. I know there should not be a middle term. So they messed up and put a middle term there because those middle terms would actually cancel, right? It should have been minus 12a and plus 12a, and those would have canceled out, and I would not have a 24 there. I would have a 0. All right, that is it for this video this week. So next week, what we have left is dividing polynomials. So you will see a video on that come up next week. I hope this was helpful. Thanks, everybody.